Hi, Year 11, this is Mr. Lim here again, and this is our 14th video on hydrocarbons. We're almost there at the end. This is the first video about observations of reactions. So let's get started. Okay, we're going to be learning about how to predict what a reaction would look like using the data sheet, and we're going to have to identify a whole bunch of colors and what stuff looks like. All right, so the observations are for addition and substitution reactions can be predicted using the information provided on the data sheet. All right, and the pages on the data sheet that you're looking for is page 5. Okay, so if you have your data sheet with you, which you should definitely have your data sheet, go and turn to page 5, and then you can follow along. All right, so halogens, so that's halogens, not hydrohalides. So that is things like Cl2, F2, Br2, and I2. Those are halogens, not halides. Oops, that's not what I wanted. Halides, which are halogen ions, which are your again, not what I wanted. Cl minus, F minus, Br minus, and I minus. Okay, so we have to differentiate between what we're looking at here. Halogens, that's these, versus halide ions are different things, right? And so that's why they're named different. So let's go have a look at what we got. So halogens are colored substances, and they're different colors in different states. Okay, so the data sheet identifies the colors of halogens in the free element state. So what you will be looking for is somewhere in the middle of page 5, colored halogens. And so you can see colors of halogens in color of free element, color in aqueous solution, and color in organic solvent. Okay, so if you look at chlorine as a free element, it is greenish yellow, but chlorine in an aqueous solution is pale yellow, right? Or fluorine as a free element, as a gas, is yellow. Fluorine doesn't form aqueous solutions, right? It actually reacts with the water, and then fluorine doesn't have an inorganic solvent either. But if you look at bromine as a free element, it's liquid, it's red, right? But bromine aqueous solution is orange, but bromine in organic solvent is red. So you need to have a look, and you have to read what the question says and work out what state it's in, and then work out what color it is. All right, so you have to really know that those tables are there for a reason. All right, then halide ions or halides, or halogen ions, are all colorless. Okay, so Cl2 got a color, Cl minus got no color. All right, so all of the hydrogen halides in gaseous form are colorless, and all hydrocarbons are colorless. All right, so a whole bunch of colorless stuff, and then you add some halogens to it, and then it will turn colorless if a reaction occurs. All right, so alkyl halides like chloropropane will be colorless as well. All hydrocarbons and alkyl halides are also colorless. Okay, so making sure that you can identify what colors things are is important. Okay, when asked to write observations, you should generally split your answer into a description of the reactants and a description of the products. Okay, but look at the question, read it, because sometimes it will only say what are the color of the reactants, what are the colors of the products, and so therefore you just have to answer only that, and you'll just be wasting your time if you add in any extra information. So let's go through an example. All right, let's do propene gas plus limited, let's do chlorine gas. Okay, so propene gas, C3H6, or you can do CH2CH3, right? Plus chlorine gas, Cl2, right? And so, even in the absence of UV light, this is going to be an addition reaction because it's got an alkene, right? And so it's going to form C3H6Cl2. Alternatively, it's going to form CH2Cl, CHCl, and CH3. Or you should know that it's just going to form 1,2-dichloropropane. All right, so we should be able to say what the colors are All right, also you should write down what states these are in. So these are all in gaseous, right? And they generally stay in the same state that they were in before, right? So let's go look at the colors of the stuff at the beginning. Propene gas, we should remember that all halogens are, no, not all halogens, all hydrocarbons are colorless. So it's a colorless gas is added to a, then what color is this chlorine gas, which is chlorine is a free element, a greenish yellow gas. So that's the description of your reactants to form a colorless gas, which is your dichloropropane. Yeah, 1,2-dichloropropane. All right. So when you're doing observations, you're asked to describe what things look like, but not identify what they are. So you can say colorless gas, but you can't say the colorless gas propene is added to the greenish yellow gas chlorine gas. So you should just say what color it is and what it looks like. All right. So that would be an example of that particular reaction in either UV or no UV light. Okay, that's one option. Okay, let's go do another one. Erase faster, Mr. Lim. Okay, so let's do iodine water, which is iodine as an aqueous solution, right? Is added to not propane. Let's do methane gas. Or methane gas is added to iodine water because generally you would bubble the methane gas through the iodine water, right? So iodine water is added to methane gas. So iodine water is I2 aqueous. Okay, so when it says water, it means it's the halogen that is dissolved in water and is added to methane gas, and let's just say excess methane gas, right? So it's going to be added to CH4 gas, and it's going to go to, what is it going to go to? Let's write, first of all, it's in the presence of UV light. Otherwise, this reaction wouldn't occur. Right? So what's going to happen? It's going to form a higher alkyl halide. It's going to form what color should I use? CH3I and HI. Okay, but HI is going to be in aqueous form, and the CH3I is, well, you don't really know what state this one's going to be in, but I'm just going to say that it's a gas. Right? I'm not really sure if it's a gas, but I'm just going to say it's a gas. All right, so that's that one there. Right, so then what does it look like? What do the reactants look like? So I have a brown liquid, which is the I2, has a colorless gas, which is the methane, bubbled through it. Okay, which means that you're just adding the methane to it, right? And then what happens? It forms iodomethane and hydrogen iodide, which are both colorless substances. So the brown liquid changes to colorless or decolorizes, and that's all that you see. Okay, so if you've got it in a big enough container, the bubbles of methane gas will disappear as they react, but generally you just say that, it just changes to colorless. The bubbles will generally get to the top, unless you've got a really contained container, right? So brown liquid changes color to colorless. That's the idea of that one there. Identify the reactants, identify the products, identify the color of the reactants, identify the color of and appearance of the products, and then go from there. All right. We'll have practice of this in class and we'll see how we go. Adios.